So starting with multiplication. Now, with multiplication, go ahead and multiply them. Now, I am going to give you one little sort of exception. I'm not going to multiply 54 times 5. I'm just going to leave it as 54 times 5. I am going to multiply the x's and the y's. So x to the second, x to the third, I get x to the fifth total, following my exponent rules, and y to the seventh. All right, now here's the reason I didn't multiply the 54 and the 5. I'm going to split this apart to look for groups of 3. So there's no reason to multiply the 5 with it because I just have to split it apart anyway. So 54 is 9 times 6. 9's 3 and 3. 6 is 3 and 2. And then I'll bring my 5 down. So I've got a group of, remember it's cubed root, so I'm looking for groups of 3 of a kind. So I've got a group of 3 3's. My 2 and my 5, or 10 total, don't have groups. Okay, 3 goes into 5 one time with 2 left over. And 3 goes into 7 two times with 1 left over. All right, multiply together first, then simplify. It'll be a lot easier. All right, so I'm going to sort of do the same thing. The only reason that I wanted us to do this one is because of this negative right here. Now, my only way to get groups of 3 of a kind is to make these negatives. Then I've got a group of 3. So if you need to do that, that's fine, as long as you still end up with the same value, like negative 5 times negative 5 is 25. So that's fine. Okay, let's divide. Now, division is honestly pretty much the same as multiplication most of the time. Go ahead and divide. They do need to have the same root here. Once you've divided, then simplify down. So 32 divided by negative 4, and I do actually divide on these, is negative 8. And then with the negative, I'll need to put negatives on all 3 of those. So negative 2. So divide first, and then see what you need to do from there. So I'll have 4, okay, 4 minus 1 is x to the third. Square root of 4, this is like a 2 here, is 2. 2 goes into 3 one time with 1 left over. Okay, and same thing here. This number's a little bit big, but 162 divided by 3 is 54. And then I have 5 minus 2, x to the third. And let me rewrite that there since you can't really see that in the blue. And then I'm going to break this down. So 54 is 9 times 6. And I think we had 54 a minute ago. So I've got a group of 3, 3 cubed root of 2. With the x's, 3 goes into 3 one time with nothing left over. Now you could run into one fairly large issue with division, and it's in these last 2 problems that we're going to have. Here's the issue I'm running into. 3 doesn't go into 2. Same kind of idea here. I can't divide the bottom into the top. It's just not going to happen. The numbers just don't work out. When you have a situation like this, what you want to do is called rationalizing. It's called rationalizing the denominator. Basically, your goal is to make sure your answer does not have a square root or a cubed root in the denominator. So what I'm going to do in order to fix that is I'm going to multiply by square root of 3 in this particular problem. The reason I'm going to do that is because square root of 3 times square root of 3 is 3. It's square root of 9, and square root of 9 is 3. The top, it's okay if you have a radical there. Now you do want to double check and see that you can't simplify. 3 and 6 would simplify, but the 6 is in a square root, the 3 is not. So that's as good as it gets. Now I do want to give you one suggestion. If you can simplify before you rationalize, it's worth your while to do that. Now here's what I mean by that. Before I do anything else, I could simplify my x's here. So I would end up with 3 minus 1 is 2. And I've got a group of 2, so square root of x squared is x. And then I'm going to rationalize. So I'll multiply by square root of 5y. So x square root of 5y over 5y. Now, like I said, you'll save yourself a lot of time and a lot of energy if you make sure to simplify first. Now, technically, you'll get the same thing regardless, but it will save you some time and some energy. So today in 7.3, we're going to look at adding and subtracting with radicals and then multiplying and dividing. Okay, so here's the deal. When you're adding and subtracting, you have to have like terms. Now that means the radical has to be the same and what's inside the radical has to be the same. If they're not, you can't add or subtract them. Here they are, so I can subtract 5 minus 3 is 2. Keep that like term. This one I can't add because the 2 aren't the same. This one's square root of 2, this one's square root of 3. This one I can't do because this one's fourth root, this one's cubed root. So they've got to be exactly the same. Now, here's the deal. Most of the time they're not the same. So you do want to make sure that you simplify things down and see if you can get them to be the same. So here, I'm going to think of 18 as 9 times 2 because I can take the square root of 9. So I'll have 3 root 2. Now that simplifies to 18, and I'll keep doing that. So 8's 4 times 2. So I've got the 4 that was already there, and then 2 root 2. Okay, so when I multiply there, I'll have 8 root 2. And then finishing off here, 72 is 36 times 2. So I'm going to bring the 3 down. Square root of 36 is 6 root 2. Now see how I was able to get them all in terms of root 2? Because I could do that, I can actually go through and add now. So 18 minus 18 cancels out, plus 8, so 8 root 2. Okay, let's do one more. Same thing, they're not all the same, so I can't add and subtract them as is, but I'm going to simplify down. This is 25 times 2, so 5 root 2. 16 times 2, let me go ahead and bring down the 3, 4 root 2. And 9 times 2, go ahead and bring down the negative 5, so 3 root 2. Okay, get these cleaned up a little bit before I combine my like terms, so 12 root 2 minus 15 root 2. So I've got 17 minus 15 is 2 root 2. So combine the like terms. Okay, second thing we're going to look at is multiplying and dividing. Now when we're multiplying, follow all the same normal rules you would follow. Distribute, FOIL, that kind of thing. Looking at this, I can FOIL these together. So I'm going to do first outside, inside, last. Now I'm going to write out what I have on the last. I have 8 times root 25, which is 5. So 8 times 5 is 40. You can go ahead and combine those. And then I can combine the 6 and the 40. So 46 plus 16 root 5. Okay, now I'm going to do the same thing over here, but I'm going to go ahead and rewrite this out. It's squared, so I'm going to write it out. So I've got first, outside, inside, last. So 2 times 3, now this is 3 right here because it's square root of 3 times square root of 3, which is square root of 9. So 2 plus 3 is 5 minus 2 root 6. Okay, last multiplying one we're going to do, I want you to look at this, and there's a word I want you to be familiar with. See how these are exactly the same except one is a plus, one's a minus? The term for that is conjugates. They're conjugates of each other. Now I want you to see what happens when I FOIL these together. So I've got first, outside, inside, and I don't know why I put a 5 there instead of a 3, last. Now see how these cancel out? So all I have is 4 minus 3, which is 1. What I want you to notice is the canceling that happened there. That's going to happen every time with conjugates. Okay, now the last thing we're going to look at is division. Now we did a little bit of division in 7.2. What's different here is that in your denominator you've got things, it's a little more complicated, you've got things added or subtracted together. Now here's our goal. We'll remember this terminology from our last chapter. What we want to do is rationalize the denominator. Now that means get it to where there's no square root in the denominator. Now here's how you're going to do that with these more complicated ones. You're going to multiply it by 1 plus root 5. Now see how those are conjugates of each other? Conjugates, same thing, but one with a plus, one with a minus. Let me go ahead and balance up here. Now I want you to see what happens when I go through and I FOIL these together. Now I'm going to focus on the denominator first. So I'll have 1 plus root 5 minus root 5 minus root 5 times root 5 is root 25, which is 5. Excuse me. Before we look at the top, here's what I want you to notice. Those cancel, which will just leave me with 1 minus 5 is a negative 4. Okay, now let's FOIL the top. So I'll have 3 plus 3 root 5 plus 1 root 5 plus 5. So I have 8, 5 plus 3, and 3, 4 root 5. Now that's great. I do think I can do a little bit more because 4 will go into each of those terms. So I'm going to divide that negative 4 into the 8 and cancel them out here. Okay, let's do one more of these. Alright, so here's what I have. I'm going to multiply by the conjugate. This one has a minus there, I'm going to do it with a plus. Balance on the top. So on the bottom, I always like to start on the bottom, I have 16 plus 4 root 15 minus 4 root 15. They cancel, minus 15. So when I get those combined, it'll be a 1. Okay, on the top, and I forgot my 1 right here to make the 15, I'll have 24 plus 6 root 15 plus 4 root 15 plus 15. Okay, combining the 24 and the 15, I get 39. And combining here, 6 plus 4 is 10, root 15. Now 1 goes into each of those, so I have 39 plus 10, root 15. Alright, rationalizing denominators, it's something that you'll see quite a lot, so it is something that you want to make sure you get the hang of. If you've got questions, make sure you come in and see me.